All right, our video here is going to be about the direct comparison test. And the theorem from the online textbook says that if there is an integer n such that a sub n is less than b sub n and all of those are greater than 0, for all n bigger than just this term, okay, then if bn converges, then an converges. It's kind of like the squeeze theorem. Okay, so it's not for like term maybe 1, 2, or 3, but as you get out into larger n terms, okay, is what this means. If b sub n is always bigger than a sub n, then it's going to sandwich it between 0 and b sub n, and we can say, well, if b sub n converges, then a sub n must converge. Also, like the other side of that is true. So if you know that there's a series a sub n that's always bigger than something that diverges, then if b sub n diverges, then a sub n is bigger than that, it must also diverge. Let's look at a couple examples. So just like we had parent functions, I like to think of these as like parent series, if you will. And what I mean by that is like I look at this leading term here on the bottom, and I'm like, okay, this series looks a lot like 1 over n cubed with some other stuff, okay? Now, I know 1 over n cubed converges by the p-series test. So I need to show that this, which is my b sub n, all right, let me go back up here. Oh no, this is my a sub n. This is what I'm calling my b sub n, which converges, that I need to show that a sub n is always smaller than b sub n. Here's something that I want to make sure that I draw your attention to. If I know that 4 is always less than 5, then something else that is true is that 1/4 must be greater than 1/5. Okay, so if you have two numbers or set of numbers that's this relation is true, less than, greater than, okay, and you take the reciprocal of them, then it must be true that that sign gets reversed. Why does that matter? Well, because I know that n cubed is going to be smaller than n cubed plus 3n plus 1. Because if I have numbers that I'm adding to n cubed, that right-hand side is going to be bigger than just n cubed all by itself, okay? I could say this, like that's also true. So what does that mean? Well, then if I flip these, if I take the reciprocal of them, then this must be true. And because n's always positive, I know that this must be true. So if 1 over n cubed, that series converges and 0 converges, then I know that a is going to converge. Okay. All right, let's look at b. Now again, I'm going to look at b and I'm going to look at this as like essentially a parent series, if you will. I don't think it's really called that, but that's what I call it. And so when I'm looking at this, I'm thinking about looking at 1 over 2 to the n. So what is the series 1 over 2 to the n or 1/2 to the n? Well, this is going to converge because it's a geometric series. Okay, with r less than 1. Now, if you're going back to the geometric series, yes, it needs to be n minus 1, and we're not finding the sum, so I'm not really worried about like taking the a out and finding all of that. I just know that because r is less than 1, absolute value of r is less than 1, this is a convergent series, okay? All right, so then let's do our comparison here. 2 to the n is less than 2 to the n plus 1. Like that's always true. 2 to the n is going to be less than 2 to the n plus 1. And again, I'm using this part right here and then my parent series to make that. So what does that mean? That means that 1 over 2 to the n must be greater than always 1 over 2 to the n plus 1. And this is always positive. Since 1 over 2 to the n converges, this series must converge. All right, let's look at this bottom one, okay? Now, when I'm looking at natural log, I know that like just overall things with natural logs cause some problems, right? Let's think about a series maybe that diverges. So I know that the harmonic series 1 over n is divergent, right? Now, what is true about the natural log of n and just n? Like if I think about those functions over time, if I take the log of a number, that's going to be smaller than that number. And you can look at a graph, okay, like x, and then natural log of x, and you can see that, okay? The natural log of a number is going to end up being smaller than just that number. What does that mean? That means that 1 over natural log of n must be bigger than 1 over n. Well, if 1 over n diverges, and so this is bigger than it, then that's going to diverge. Okay, so this is all about picking a function that you know. Usually these are going to be p-series functions or geometric series functions. So always think about those two things and thinking about it like almost again like a parent series and seeing if you can compare it. And then going back to like this numerical reasoning is always true and using that to help you figure out the convergence or divergence of your a sub n that you're given.